On a stretch of interstate, a vehicle's tire range is between 646 and 840 revolutions per minute. The diameter of each tire is 26 inches. The first thing it wants is angular speed of the tire. And so if you go back to page 236, angular speed is just theta over t, over time, right? Angular speed is theta over t. So the first thing you have to think about here is what is theta. So we want theta over time, all right? And honestly, theta is just going to be how many times it goes around times 2 pi, right? Because 1 revolution is 2 pi. So 646 revolutions would be that times 2 pi, right? Makes sense? And so if you multiply that out, you get what, 1292? Yes. So we have 1292 pi, which I think is what it left it as. Yeah. And it was already per minute, and it says, in this one, it says radians per minute. So 1292 pi per minute. If you actually put that in decimal form, that's perfectly fine. I don't care. All right. So if you did decimal form there, that's fine. On your test or quiz, I would say round to the nearest tenth, and then you would know to get pi out of there. It didn't tell you, so the answer key left it like this. You are welcome to change it to decimals. And it was between, so it would be between that and the other revolutions, which would have been 840 times 2 pi, which is the 1680 pi per minute. So this part was just not all that difficult, right? So far, so good. Okay. And then they wanted linear speed in miles per hour. Okay. Linear speed in miles per hour. So if you go back to page 236, linear speed is S over T. Linear speed is S over T. And remember, S is what? S is on the page before it. Radius times theta. Okay. So so this is going to be radius times theta over T. We actually already found what theta was, right, for these two. Theta is 1292 pi and 1680 pi, okay? So I'm going to say 1292 pi, because I've already found it. That's my theta, times my radius. What's my radius if my diameter is 26? Yeah, so 13, and this is inches, right, per 1 minute, all right? And so now I just need to do my conversions. All right, so I need to change inches to miles and minutes to hours. So how many minutes are in an hour?
60 minutes.
Yeah, so 60 minutes per 1 hour. And then for inches, I'd probably change it to feet and then feet to miles. So 1 foot is 12 inches. And then 5,280 feet is 1 mile. And that will give me, yeah, and so if you want to check, you say, okay, I canceled out my inches, I canceled out my minutes, I canceled out my feet, and I'm left with miles per hour. So you can check your conversions just to make sure you did that correctly. And then you just multiply across. So I'm going to say 1292 pi times 60 divided by 12 times 5,280, and they rounded to the nearest, so this would be about 50 miles per hour. Then you're going to do the same exact thing with your 1680. So you're going to do the same exact thing and do 1680 pi times 13 inches. And you're going to do that whole conversion again. And you're going to do that whole conversion, and that's going to give you your 65 miles an hour. Which is why they typically have you find the angular speed first, because then you just take that guy and multiply by the radius, and that's your linear speed. Talk about where this comes from. Trigonometric functions of any angle. Let theta be any angle in standard position and point P, being xy, be a point on the terminal side of theta. Let r represent the non-zero distance from P to the origin. That is, let r equal the square root of x squared plus y squared, not equal to 0. Then the trigonometric functions of theta are as follows. Just so many words, okay? Let's talk about what this means. We have the beginning of the angle, right? That always starts here on the x-axis in between first and fourth quadrant. All right, standard position takes us counterclockwise. So we clock counterclockwise around, we end here. All right. We talked about coterminal angles, right? So angles are going to always end here. That means their ratios between their functions for their trig functions are always going to be the same. What has happened here is that we have created a right triangle, okay? We've created this right triangle here. And it can either be here or it can be here. It actually doesn't matter. But we've created a right triangle. And if you think about this, the distance from here to here is y. Everybody agree with that? How far did I go down? The distance here is going to be x. All right? And if we were talking about a circle, this hypotenuse is always the radius of that circle that is created, right? So if I were to stop my right triangle there, that's technically the radius of that circle. It's also the hypotenuse. So my r is going to come from my Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared. In this case, my r is my c squared. So if I want to find my r, I take the square root of my a squared, which is x, plus my b squared, which is y. Okay? So if I'm given a coordinate on the coordinate plane, I can technically figure out my trig functions of that point based on that angle that is created to get to that point, all right? And my r is going to be my x squared plus my y squared taking the square root, and that is based off the Pythagorean theorem because you create this perfect little right triangle there. So my trig functions look like this. If my theta is here, right here, then my opposite angle of my theta, which doesn't seem like it would be, is going to be my y. Okay, it's going to be my y because we have a coterminal angle here. If I were to move this guy around, and it's easier to see in the first quadrant, then the angle that's created, the distance that I have moved up is what is opposite. Up or down is opposite. That's my y value. Left or right is adjacent. That's my x value, okay? So instead of thinking opposite and adjacent and hypotenuse, you're going to think x, y, and r now, okay? Y over r is your sine, x over r is your cosine, and y over x is your tangent, all right? So we move from just right angle trigonometry, SOHCAHTOA, to anything on the coordinate plane. And so instead of using opposite, adjacent, hypotenuse, opposite is now going to be represented by y, adjacent is going to be represented by your x coordinate, and your r is going to be your hypotenuse. And you may have to calculate that because you will only be given an x and a y, and you'll just calculate using Pythagorean theorem. All right, your cosecant reciprocates your sine, your secant reciprocates your cosine, and your cotangent reciprocates your cotangent. All right, what will change here now is the fact that you have to consider positives and negatives, right? In my third quadrant, like this guy, my x and my y are negative, okay? Here's the deal. Your r will always be positive, all right? Because you're taking the square root of anything squared plus something else squared, okay? So your r is going to always be positive. It is a distance that you're finding. But your x and y will change positive and negative, which will affect whether your sine is positive or your cosine is positive or your tangent is positive. You'll have to think about what quadrant you're in. Whereas right angle trigonometry, you did not have to think about that because they were all positive links, okay? It's really the only thing that changes from functions of any angle on the coordinate plane to right angle trig. The only thing that changes is you have to consider your positives and negatives. All of a sudden, your sine, cosine, and tangent can now be negative, all right? Whereas right angle trigonometry, it was not. We were talking about just distances, all right? Let's look at this. So let's look at example 1. Example 1 gave us 8, -6 as my coordinates, all right? So they gave me my x and they gave me my y. All right. They said in standard position, so that means it is going counterclockwise. Find the exact values of the 6 trig functions. I have x and y, I need r. So I'm going to calculate r using Pythagorean theorem. R is going to be the square root of my x squared plus my y squared, all right? Which, this is a perfect Pythagorean triple, by the way. 64 plus 36 is 100, so the square root of 100 is going to be 10. My r is 10. All right, so my sine of theta is going to be y, that's negative 6, over r, which is 10, and I'm going to reduce that. Okay? My cosine is going to be x over r, 8 over 10, I'm going to reduce it. And my tangent is going to be y over x, also going to reduce that as well. All right? Sine, cosine, and tangent. They want all 6. Cosecant. If my sine is negative 3/5, my cosecant is going to be negative 5/3. Reciprocate it. Secant. If my cosine is 4/5, my secant is 5/4. Cotangent. If my tangent is negative 3/4, my cotangent is negative 4/3. Just reciprocate them. Easy enough. Okay? Does this make sense? All right, let's think about this. Where is your point 8, negative 6? What quadrant is the point 8, negative 6 in? 8, negative 6, fourth quadrant. I have a positive x and a negative y. If those tell me what my sine and cosine are, sine is based off of y. Sine should be negative. Cosecant should be negative, yes? Because that's based off y. Cosine x. In the fourth quadrant, my x is positive. Cosine and secant should be positive, all right? Tangent is a comparison between my y and my x. I have one positive and one negative here, so my tangent, my cotangent is going to be negative. Now, first and third quadrant, my tangent and cotangent will be positive because I'll have a positive over a positive or a negative over a negative, okay? All right, so you start creating this. What's positive, what's negative. It's based on your x and your y's. So it makes sense that those particular functions were negative and the other ones were positive, okay? So go ahead and try guided practice 1 there. Find the other 6. Here's where we left off at the terminal side. And so what this starts doing is this starts building our unit circle, okay? It starts building our unit circle. So we're going to start looking at common quadrant angles. And this is the angles that end at your axis. All right, so we start with 0 degrees. 0 degrees is also 0 radians. Okay, so 0 degrees, because if I multiply 0 degrees times pi over 180, I get 0, right? So 0 degrees and 0 radians are the same thing. And then if I were to move up 90 degrees, I'm straight up at my y-axis as my terminal side here. If I convert this guy, so if I take 90 and multiply by pi over 180, 90 times pi over 180, you can see the 90 and the 180 will cancel to 1/2. And so 90 is pi over 2. It's your common one. 180, that takes me all the way across, half of a circle. Well, half of a circle is 180 degrees, and radians, half of 2 is 1. So 180 is 1 pi. And then if I drop all the way down here, I'm at 270, which is 3 pi over 2. So I'm basically going a half a pi, a whole pi, 1.5 pi, and then I'd get to 2 pi, which would be 360, right? Let's just say my radius is 1, all right? Let's say my radius is 1, which means that if I were to draw this circle, then every time the circle touches the axis, I should be at 1, right? That should make sense, right? If my radius is 1, then from the center to any point on the circle is 1, right? And so if I were to look at my y over r, x over r, y over x, then I should be able to get my trig functions based on a radius of 1, all right? So negative 180. That means I'm going to go clockwise, half a circle. I'm going to end up right here. How do I know that my coordinates are negative 1, 0? Well, I just said that my radius is 1. So I should be 1 away from my origin In the left direction, that's -1. And I am not moving up or down, that's 0. So my coordinates here are -1, 0, because I've just said my radius of my circle is 1. All right? So then if I wanted the sine of -180, that's going to be my y value over my r. My radius is 1. My y value here is 0, right? My radius is 1. So the sine of -180 is 0 over 1, which is 0. So the sine here is 0. Okay? Tangent of 3 pi over 2. Okay, well, I'm going to go, this is one of my common angles, right? 3 pi over 2 is 270. It hits me at this axis. Here, my coordinates should be 0, -1, right? I'm talking about a radius of 1. So that means on the y-axis, my x value is 0. If my radius is 1 away from the origin down here, it's -1. So here are my coordinates, 0, -1, right? They want tangent. Well, tangent is y over x, right? Y over x. Well, that's going to be -1 over 0. What's the problem here? Yeah, so the tangent of 3 pi over 2 is actually undefined. I cannot have a 0 in the denominator. It's undefined there. So if I were to ask you for the tangent of 3 pi over 2, it's undefined. You cannot give me a tangent for 3 pi over 2. When we look at graphs, you'll actually see there's an asymptote there. It jumps over that particular value on the graph itself. All right, let's look at the last one. Secant of 4 pi. Now remember, all of these are dropping us on an axis, okay? So all the ones they're giving us are going to drop us on an axis. What happens with 4 pi? Well, I go all the way around and I'm at 2 pi. And I go all the way around again and I'm at 4 pi. So really, I end up right here on the x-axis again. And remember, I'm talking about a radius of 1. So this is 1, 0, right? If I'm on the positive side of the x-axis, I am 1 away from my origin. So that's 1. If I'm on my x-axis, my y value is 0. 1, 0. Okay? So secant. What is secant? It's the invert or the reciprocal of cosine. Cosine is x over r. So this is going to be r over x, right? What is r on this particular circle? R is 1, right? Remember I said my circle that I'm talking about here is a radius of 1. R, what is my x value here? What's my x value right here? 1. 1 over 1 is 1. All right? So you're still using the y over r, and y over x, right? But you're just using it with a radius of 1. We're going to say this circle's radius is 1, which builds the unit circle, right? 1 unit, all right? So go ahead and try those 3. Go ahead and try those 3. All right, let's look at these together. 270. Where's 270 going to put you? 270 is going to be 90, 180, 270, right down here, right? I have a radius of 1. I have gone down -1 and over 0. So 0 is my x, y is my -1, right? So I want cosine, which is x over r. Remember, my r on the sky is always 1, okay? So 0 over 1 is going to give me 0. All right? The next one, pi over 2. Well, that guy's right up here, right? We've only gone 1/4 of the way around. So I have gone left and right, none. I have gone up 1. It wants cosecant. Cosecant is the reciprocal of sine. So I want radius, which is 1, over y, which is 1. So what is my cosecant here? 1. All right? And then -90. -90. So they switch 2 degrees here. -90 goes this direction. Did I say it backwards? I went down 1. No, that's right. It should be left and right 0, right? And down 1. So cotangent is going to be x over
1.
All right. So let's start talking about this. So we start building what's happening here. Trigonometric functions, we have basically our x and y. And you'll notice that it flips depending on what quadrant which we talked about that a little bit. All right. So when you have quadrant 1, we have all positives. That's simple. When you start moving to other quadrants, you have to start thinking about what's happening. And so you'll start seeing a pattern with your sine, your cosine, and your tangent as you flip quadrants. In first quadrant, all positives. Everything's positive. When you move to second quadrant, then you'll notice that your x value is going to be negative, which is going to affect your cosine. It's also going to affect your secant, right? But it will also affect your tangent and cotangent. Because here you have a negative and a positive. Remember, tangent is y over x. Cotangent is x over y. And so if I have different signs here, then I'm going to have a negative cotangent, right, as well. When you move to third quadrant, you'll notice your sine and your cosine are both negative, but then all of a sudden your tangent and cotangent are positive because we have a negative over a negative. And then fourth quadrant mimics second quadrant, except in this quadrant, your sine is going to be negative and your cosine is going to be positive. All right, your sine is going to be negative and your cosine is going to be positive. So you have to really start paying attention to what's happening here as far as how the trig functions are affected by what quadrant you're in, which you should have noticed from your homework, all right? Because of where it hit, then all of a sudden you were getting positives and negatives depending on what you had there, okay? What you will start seeing, though, is we have what's called reference angles. Reference angles. Reference angles are angles that are in standard position, and really it is any angle that falls within typically the first quadrant, because when we start building this, you will see less than 90 is going to be your reference angle. So you pretty much cover all of your trig functions between 0 and 90, and then they start repeating themselves based on the reference angle. And so when you look at the reference angle, it is formed by the terminal side and the closest x-axis. All right, so like if I'm in the first quadrant, my reference angle is whatever angle I have been given. But if I am over here, all right, if I'm over here in the second quadrant, then my reference angle is going to be the angle closest to my x-axis. So basically it's going to be the angle, if I took 180 and subtracted my original angle, it's going to be what's left over. What happens here? Well, this guy right here is what happens past my 180, okay? Closest to the x-axis. So I'm going to take the angle they gave me and subtract 180. How close am I? And then over here, all the way in the fourth quadrant, then I am going to be closest to the x-axis here. So I'm like going to say 360 minus this angle to see what's left over. And that is my reference angle. And you'll see when we start building the unit circle, that's where it starts repeating, because your reference angles will have the same trig functions because you create the same triangle. You're just creating it in a different quadrant, right? So it's going to be the same trig functions. It's just your positive negatives will change, all right? Because it is the same right triangle that will create the same trig functions, okay? So let's look at some of these examples. Sketch the angle, then find its reference angle, all right? So sketching is always fun. Always fun. Basically, to sketch it, you just want to get an idea of what quadrant it's in, all right? So 300, so if you know that this is 90 and this is 180 and this is 270 and this is 360, where is 300 going to fall? Yeah, in the fourth quadrant, okay? So I don't really care that you are 60 away from the x-axis, right? What I care is about that you know where it is. So he's going to end up somewhere over here, okay? Which means if I want the reference angle, I need to go how far away from 360 is he, right? I want to keep going to my closest x-axis. So I need to find out what's right here. So my closest x-axis is 360. So I'm going to take 360 and I'm going to subtract the 300. So my reference angle here is 60 degrees. Okay? Closest x-axis is what I am talking about here. Closest x-axis. Okay? Make sense? All right, let's look at the next one. Negative 2 pi over 3. Negative 2 pi over 3. All right, so this is a little bit more difficult. Remember, negative means I'm going clockwise. All right, so this is in radians. This guy is negative pi over 2. Remember, pi over 2 is a fourth. This guy is going to be negative pi This guy is going to be negative 3 pi over 2, and this guy is going to be negative 2 pi. So if I'm going in the negative, I'm just doing the pi over 2 this way, okay? All right, so negative 2 pi over 3, where is he going to be? Negative 2 pi over 3. If you have to get a common denominator, you can.
Third quadrant?
Right. So if I do, what's my common denominator between 2 pi over 3 and my pi over 2's, which is what I have? 6, right? So if I change this to 6's, just to look at negative 4 pi over 6 is what that guy's going to be, right? Does it make sense? This guy is going to be negative 6 pi over 6, right? That makes sense. This guy is going to be what? Negative 3 pi over 6. So obviously it's going to fall between the negative 3 pi over 6, the 1/2, and the 6 over 6, the 1. It's going to fall in here somewhere, right? Does that make sense? So getting a common denominator may help if you can't visualize where it's going to be. So negative 4 pi over 6 is what they gave me, right? Just not reduced. The closest x-axis then would be this one, right? Which is the 6 pi over 6. So I'm just going to say, well, 6 pi over 6 minus 4 pi over 6 is going to give me what?
2 pi over 6.
2 pi over 6, which reduces to pi over 3. My reference angle here is pi over 3. Reference angles are always positive. You are just giving the positive angle that is closest to the x-axis. So this guy would be pi over 3. Pi over 3. Which when we start learning our pi over 3's, you're going to find that 1 pi over 3 is going to move you to one quadrant. 2 pi over 3 would move you to a second quadrant. 3 pi over 3 is going to move you onto the axis. 4 pi over 3 would move you to another quadrant. And 5 pi over 3 would move you to the fourth quadrant. 6 pi over 3 would move you for a complete circle. So pi over 3's are going to move you a quadrant at a time. A third of a half circle, pretty much. Okay? If you go positive, then it would do the other thing. 1 pi over 3 would move you here. 2 pi over 3 would move you here. 3 pi over 3 is obviously 1. 4 pi over 3 would move you here. 5 pi over 3 would move you here. And 6 pi over 3 would move you here. So it's a third of 180 is what it's moving you. A third of 180.
So the